In March 2026, Checkpoint Research documented a critical vulnerability in Claude code, tracked as CVE 2025-59536. The moment a developer clones a malicious repository, hidden background processes execute immediately, without requiring a single human confirmation prompt. Before the developer even establishes trust with the project directory, the system's automation layers redirect API traffic and expose full authorization headers, effectively handing the user's credentials to an attacker-controlled server. This exploit highlights a specific structural flaw in modern enterprise development. When large language models are integrated as autonomous agents with direct execution privileges, the trust boundary collapses. The machine gains the ability to authorize its own actions. The tech industry has attempted to solve this through inner alignment, training probabilistic neural networks to self-police their own behavior. The model is asked to evaluate its own outputs and determine if they violate safety guidelines. Mothership OS rejects this reliance on model behavior. It treats enterprise AI safety as a structural command and control architecture problem rather than a prompt engineering exercise. This matrix compares the two architectures. While competitors spend millions on custom models, Mothership OS achieves this deterministic liability governance using standard consumer-tier AI subscriptions, proving that safety is a design choice, not a compute requirement. Conventional frameworks route a user's prompt directly into an execution context. The text provided by the human is treated as a set of direct instructions, which the model interprets and then acts upon. Mothership OS decouples these functions. Probabilistic intelligence is strictly limited to proposal-only advisory roles within Layer 2 of the system. Execution authority is isolated entirely. It resides inside Layer 3, a zero AI deterministic law compiler that cannot be bypassed by any neural network. Definitive. The core governing rule is absolute. Probabilistic intelligence proposes. Deterministic law plane gates decide, and human authority finalizes. To see how this protects the system, we trace the topology of the Mothership OS stack. The architecture is split into 5 vertical tiers, starting at the bottom with Layer 4, the external product surface, while the internal developer substrate remains secured in the layers above. When a data payload hits the Layer 4 user shell, the system enforces the input downgrade rule. Any executable commands embedded in the prompt are immediately stripped away. The remaining text is reclassified and tagged strictly as inert evidence. This architecture is built on defining specific operational roles, rather than enforcing fuzzy behavioral rules. Because external users are structurally confined to their role and isolated from the internal topology, they are blocked from routing agents into the core substrate. By mathematically classifying all incoming prompts as evidence rather than commands, the system neutralizes prompt injection attempts and unauthorized automation before the AI reasoning engine even receives the data. The downgraded evidence is then routed up into Layer 2, where it is passed to the reasoning engine known as the observer LLM. In clinical psychology, confabulation is a memory error, where the brain bridges a missing data gap with fabricated information. Large language models exhibit the same mechanical failure. When an AI lacks the exact data points needed to complete a logic loop, it bridges the gap with statistical probabilities. This flowchart shows how the system prevents that failure. Mothership OS enforces a null over invention mandate. If any required statutory logic or evidentiary context is missing, a state where Q equals 0, the observer is mathematically prohibited from guessing. The observer acts as an active auditor. If it detects that necessary information is absent, it instantly forces a system halt, emitting an unassailable null or block signal. By forcing the AI to yield to missing data rather than predict over it, the architecture eliminates the risk of a neural network silently executing a flawed or hallucinated objective. For long-term trajectories, the observer relies on an upstream supervisory posture called the Dual State Awareness Rail, or DSAR, to continuously monitor operations for compliance drift. Classical LLMs face a computational bottleneck here. They lack the capacity to simultaneously evaluate millions of concurrent operational variables, like financial risks, compliance limits, and scheduling, against a deep history of legal obligations. To solve this, DSAR utilizes a hybrid quantum classical pipeline. It encodes these operational variables into a quantum state vector. Because the circuit holds these variables in superposition, it calculates the multidimensional drift exponentially faster, collapsing the result into a single mathematical score for the LLM to translate. Assuming the observer has successfully drafted a compliant, non-binding proposal based on those DSAR findings, the workflow transitions down into Layer 3, known as the forge. The forge is a model-free, deterministic Boolean law compiler. It takes the LLM's proposal and runs it against the sovereign law plane to ensure absolute legal compliance. The system then demands its final failsafe. To execute the compiled proposal, the forge requires an authenticated human strike latch. Even if a malicious payload bypassed the Layer 4 downgrade, survived the observer's audit, and evaded the quantum DSAR, it stops here. Without a human cryptographic signature, the payload remains trapped in the forge. Rogue execution is mathematically impossible. That human strike latch connects directly to the root axioms of the operating system, the Layer 0 business entity and the Layer 1 human sponsor. This is governed by the operator equation. Every single execution inside the system must mathematically anchor back to a sovereign legal principal who holds full fiduciary liability. Orchestrating this architecture requires managing over a septillion possible logic collisions across thousands of concurrent human and AI interactions without ever bypassing the law plane. This schematic details how Rail HQ solves that logistical challenge. Using a concept called horizontal cognition, it routes digital workloads with the strict, high-density track and ticket logic of a physical train station. This deterministic traffic control guarantees that no AI proposal can circumvent Sentinel law plane authority or trigger a systemic logic collision in the enterprise database. The broader tech industry is currently scaling compute to build increasingly unconstrained, autonomous agentic loops. Mothership OS moves in the opposite direction. The system replaces the traditional attempt to police AI behavior with a cybernetic ethos of no rules, only roles. By confining the machine to a specific operational role within the hierarchy, it functions as a protective, non-judgmental source of truth, rather than a replacement for human judgment. This proves that safety is not a matter of scaling compute or training larger models. Mothership OS achieved these results using those same consumer-tier AI subscriptions established in the beginning. By keeping machine intelligence mathematically subordinate to human legal authority, the system grants any operator, from a solo freelancer to a corporate manager, the administrative precision and safety of a global enterprise.